topic we cover, it'll be in two parts. So there will be an arrays 1 today and also an arrays part 2 tomorrow. Similarly, after that, we'll be talking about objects part 1 and then objects part 2, and then etc. And we do it for a few other things as well. But what that means is usually the first day is more of an introduction to say, hey, this is the very bare bones basics on arrays. And then tomorrow we'll go into a little bit more in depth around more advanced topics or more advanced concepts around arrays. Okay. So if today's thing seems a little bit simple, just bear with me. I promise it will get harder, and I also promise that we will definitely kind of try to make sure that everyone starts off on the same level, or at least has the same base understanding of a lot of these concepts. Okay, so with arrays, what is an array? That's the most common question that's usually asked about arrays, and usually with the most common answer people give is, well, it's like a list of things, right? And in fact, in Python, we actually call arrays lists, even though they operate more or less in the same exact way. So on line 3 here, I have a variable called numbers, and it stores an array. In JavaScript, the array is determined by the open and closed square brackets that we see both on line 3 and line 5, and then the arrays have things in them, and technically speaking, we call the things elements. So we would say that the numbers array on line 3 there has 3 elements. Similarly, the names array on line 5 also has 3 elements. The elements can be any data type in JavaScript, so it can be numbers, strings, booleans. It can also be functions, which we'll see later. It can also be objects or even other arrays. Okay, so basically there's no limit on what types of data points can be elements. Anything in JavaScript really can be an element. And all we need to do is make sure that that we are aware of the open and closed square brackets, which denote the beginning and the end of the array. And then secondly is every single element in the array is separated by a comma, right? So on line 3 we see the 3 numbers are being separated by commas, and then similarly on line 5 the 3 strings are being separated by commas as well. Yep, and so line 9 just goes to show that the arrays can hold any data type that we want, including numbers, booleans, strings, or variables or nulls. Okay, type of an array. So one of the things that we've been using so far is to determine whether or not what something is this type of, I guess, keyword. It's not really a function. I'll say a keyword. And so far, if I do type of a number, it will say number. If I do type of a string, it will say a string. But one of the things that's a little bit misleading is that if I do type of and I give it an array, rather than saying array, in JavaScript, type of actually responds back with object. And the reason for that is because even though we see arrays as something very distinct, underneath the hood in JavaScript, an array actually is just a very complicated or a very nuanced object. JavaScript is an object-oriented program, which really just means that fundamentally everything's an object. But the reason why we bring it up here is just because if we use type of and our goal is to determine whether or not something is an array, it's actually not very accurate, right? Because if I do type of for an array, I get back an object. But if I do type of an object, I also get back an object. So just to be cautious, this is one type of things where this is one instance in which type of may not give us kind of the exact answer we want right away. Instead, one thing that we can actually use to help us determine whether or not something is an array is the array class and the .isArray method. If you remember on the very first day of class when we talked about variable naming, I cautioned you to be careful when you use variable names to not capitalize the first letter of the first word, right? And the reason for that is because in JavaScript, when you do that, that usually indicates that we're looking at a class. And class, in this case at least, just represents a different data types that all exist in JavaScript. So we've already seen when you guys did the session on coercion, right? We saw the number class and the string class being used. Here we're just using the array class, and we're using the .isArray. So dot notation is something we'll talk about later on as well. But for now, all we need to know is that the isArray function is a function that exists on the array class. And so if all I have to do is if I just invoke that function, aka if I call capital A array .isArray function, so that at the open and close parentheses, and I pass in whatever variable I'm trying to check, that will give me back a boolean of either true or false. If it's true, then that means that thing is an array. If it's false, it means it is not an array. And so this is our most precise or our most accurate way of trying to determine whether or not something is an array, rather than using type of. Okay. And so once again, we don't need to worry too much about the array class for now. We'll talk about it in a little bit more. But the .isArray function is just what we should be using to verify whether or not something is an array. Okay, moving on. This is also something that I think we've all seen a lot of already in the first few workshops. Bracket notation or bracket access. And the reason why we saw a lot is we might not have seen it in the context of arrays, but we've definitely seen this in the context of strings, right? And in a lot of ways, we can think of a string as just a collection or an array of letters, right? So here, if I want to access, for example, the first element in this names array that we created on line 5, the way to do it is to use bracket notation. Bracket notation is basically we use the name of the variable, then we put square brackets after it, and bracket notation takes in a number, and that number is going to be the position of the element that we want, right? So remember how in arrays the position starts at 0, and because the first index is 0 and it works its way down. Here on line 7, all we're doing is passing in 0 into the bracket, which means we're looking for the element at the 0th position or the 0th index, so it's the first element. And so when I do that, I get George, and then on line 9, when I take a look at the element in position 1, which is a second element, I get back John. Similarly, I get back Thomas for number 3. And last but not least, on line 13 there, you'll notice that we're trying to access something at index 3, which means the 4th element. But the names array does not have a 4th element. And so one thing to caution here is that when you do something like that on line 13, where you're trying to access an element at a position that does not exist, what actually happens is we'll just end up getting back undefined. Okay, so JavaScript doesn't throw an error at you. It doesn't tell you, hey, like you can't do that. It just says, oh, okay, you want to access this position that's not here? Well, it's undefined because it hasn't been defined yet, but theoretically it could exist. Okay, so when you do that, just be aware that it won't return an error right away. It will just give you back an undefined value. And then similarly, if I was to want to overwrite any of those elements, if I say, hey, let's replace the first element, instead of George, I want to replace it with the string Washington. Well, that's as simple as using the bracket notation, using the equal sign, which has been our assignment operator, and then adding and then assigning this whatever value you want to replace it with. So here we're going to names. We're going into the elements at position 0, 1, and 2, and replacing them with the strings Washington, Adams, and Jefferson. So now when I look at names, I see that everything has been replaced with a new value, even though I still have 3 elements in my array. Okay. Any questions so far? I know that was a bit fast, but hopefully a lot of this also has been familiar to you as well. Any questions at all? Everyone good?
Can we sort the array?
Can we solve the arrays?
Yeah, if I want, yeah.
What does solving the arrays mean?
Sorting, I said, like if I want
Yep.
to array.
Yep. We'll talk a little bit about array functions for the second half of this, and then also tomorrow as well. Yep. Cool. Awesome. So this is basically all of this is trying to kind of get a sense that even though a lot of times arrays and strings are very similar, one of the very first things we talked about in I think the second lesson, right, is this idea between complex data types and primitive data types. So just to recap, primitives are numbers, strings, booleans, nulls, undefined, etc. And the complex data types are arrays and are arrays, objects, and functions. And so why do those two buckets exist? And the answer is just simply because complex data types can be changed, right? Whereas primitive data types cannot be changed. So we can never change a string, but we are able to change an array. And so one really quick way for us to see this is on line 7 there. I have an array of 5 elements, each of which is a character. And then on line 8, I have this string variable called brace, right? If I go into the array and I say, hey, go to your first element and change it to a G, versus if I tell a string, go to your first character and change that to a G, if I console log out both array and a string, you'll see that the G in the array gets changed because it's complex, hence it is able to be changed. But we'll see that the string variable does not get changed, right? So that means that this just kind of reinforces this notion that arrays are like strings in a lot of ways, but the biggest difference perhaps in the difference between arrays and strings is that we can change arrays, but we cannot change strings. If we ever wanted the string Grace, we would literally need to make a brand new string rather than edit one that already exists. Cool. So now we're going to move on to so that was a little bit of the background of kind of like the fundamentals of arrays. And now we're actually move on to a lot of both properties and also methods of arrays. And so when we say properties and methods of arrays, basically what this means is that these things are all kind of come pre-built in to every array you ever use in JavaScript. And so the idea is that as long as you have an array, you'll be able to access these things. And this is a bit more technical, and you won't need to know kind of exactly the details behind it, but just kind of take it for granted for now that all these things are inherited. They're all methods that are inherited from the array class that we saw earlier, where we use array.isArray. That also gives arrays other properties and methods as well. Okay. So the first one we'll talk about here is a .length property. You might have seen this already. Here, if I just do let names equal this array and I do names.length, I get back a number, and that number is going to be the number of elements in the array. Okay, so 3 means 3 elements in the array. If I do it with an empty array, then I get back 0. Okay, notice how this is .length is a property, not a method. The difference is that properties are just almost like keys and variables, whereas methods are functions. So here, notice how on line 5, when I do names.length, it's not names.length open and close parentheses, right? I'm not invoking a function. I'm just saying names.length. And so in this case, when I try to look at .length, I'm not calling anything. I'm just accessing a value that should already exist for all arrays. Contrast that with some of the methods that we're going to go over. Methods are functions, and so that means we have to call them. The most common set of methods that we're going to cover really quickly are the ones that add and remove things from arrays. So the first one we'll talk about is the .push method. .push method just adds one or more elements to the end of the array. It also returns back the length of the new array. So what does that mean? Here, if I take a look at line 4 here, I have this array called names. If I do names.push and I put in the string James at the end of it, and I console.log out names and also new length, notice how when I do this, the old names array now has 4 elements, right? And when I call .push on it, what I've really done is I've pushed this 4th element, James, onto the very end of the array. So that changes the original array of names. The other thing just to be cautious of is also, what does this function return, right? Because it is a function, I'm calling a function. And here on line 6, notice how we return whatever the return value, we capture whatever the return value is in this variable called new length. And when I print out new length, I get back 4. And so for every one of these methods that we're going to talk about, I'm going to break it down into 3 parts. There's what does the function or what does the method do? The second one is, does it change the original array? And then the third one is, what does it return? Okay. So in this case, what does the function do? The function takes in one or more things and it adds them to the very end of the array. Does it change the original array? Yes, it does, because we're changing the original array. We're adding things to it. And then lastly is, what does this function return? The function returns back the length of the new array. And so that push helps us add things to the end of it. And to contrast that, we also have the .pop function, which just removes the very last element from the end of the array. Okay, .pop only removes one and only one element from the end of the array, and so when we call it on line 6 there, notice how we don't need to pass in any arguments. It only does one thing. So whenever we call it, it will just do it. And if I go back to the previous framework we just talked about, right? What does it do? It removes one element from the end of the array and returns it. Okay, so does it change the original array? Absolutely, it does. It removes the very last element. And then lastly is, when I call this function, what does it return? And the function returns back the element that you just removed. So on line 6, when I call names.pop, that returns back the string Thomas. And here we're capturing that string Thomas in this variable called Jefferson. And on line 9, when I console log out Jefferson, I see that it is representing the string Thomas. Okay, so .push adds things to the end of the array. .pop removes things from the end of the array. there's a few more of these. The next one is actually kind of a cousin to the two we just talked about. What dot shift does is it operates just like dot pop, except rather than removing the last element of the array, it removes the first element of the array. And we call it shift because kind of like if you imagine like a list of things, if I take away the very first thing, well, now the second thing becomes the first thing, the third thing becomes the second thing, etc. Right? So everything shifts over one. And so it works just like dot pop, right? So what does it do? It removes the first element from an array. Does it modify the original array? Yep, it does, because we're removing the first element from the array. And then what does it return? On line 8, you'll see that we call names.shift. We store whatever is being returned in this variable called Washington. And on line 11, when I console log out Washington, I get back the string George, which was the element that just got removed, right? So we're removing something, and then we're returning that thing back to you. And then last but not least, we have the horrifically uncreative name method of unshift. Unshift works just like .push, except rather than adding things to the end of the array, we are now adding things to the beginning of the array. And just like .push, what does it do? It adds things to the beginning of the array. Does it modify the original array? Yes, it does. And then lastly is what does it return? It returns back the length of the new array. Right. So here on line 5, we capture the return value in this variable called new length. And when I console log out a new length, I get back 4. Any questions on those 4 functions so far? Before you ask, I will say that tomorrow we'll actually cover more of these functions or more of these methods, one of which will be to help us figure out how to add and remove things from the middle of the array, right? Because so far all we've done is add and remove things from the beginning and the end of the arrays. So any questions on anything I've covered so far? Cool. All right, so now we're going to go into a few more, and then we'll be done with this one. So I know it's quite a bit, but hopefully a lot of this is fairly intuitive. And once again, right, just reiterate, all of these come pre-built into every array you ever use in JavaScript. So these will always be at your disposal. Okay, the next one, the index of method. Index of, it works just like the string version of the same method. Essentially, all index of is that it's a search method. If I do the array.index of and I pass in a value, it will look to see if there's an exact match to that value. And if it finds a match, it will give me back the index, right? That's what we call it, index of. It will give me back the index of the first match that it finds. Okay, so here on line 6, when I do .index of George, it will say, great, do we see a George? And if so, what's the position at? In this case, it's the first element, so that index 0. So when I call it, I get back the number 0. On line 7, I search for Alexander, which doesn't exist in this array, so then I get back an index of -1 to represent that this element does not exist in our array. 2 things to be careful about here. Index of only looks for exact matches, so if I search for the string GEO, I would not get a match because GEO is not an exact match of any of the elements. It doesn't match George, even though George is inclusive of the string GEO, right? So it only looks for exact matches. And then secondly is the index of will look from left to right, and it will give you back the index of the first match that it finds. So in this case, if George was also the second element as well, we would still get back 0 because as we search from left to right, as soon as we find the first match, we stop. Okay, so index of only searches left to right, and it will give you the first exact match that it comes across. Another method that we also use to make copies. Sorry. Before I move on, so what does it do? It looks for an exact match. What does it, or rather, does it change the original array? It does not change the original array. This is purely a searching function. And then lastly is what does it return? It returns back the index of the match if it finds one, or if it doesn't find a match, it returns back -1. Okay, cool. All right, so the next one we have up is the .slice method. .slice is basically our way of making copies of arrays or part of arrays. Typically speaking, when we use .slice, it will take in 2 arguments. The first argument is the index in which it will start the copy, and the second number, and that is inclusive, so it includes that index. And then the second number is the element out, or the index at which we stop the copy, but we stop before we get to that number. So if I look at this on line 6 here, right, if I call names.slice 1, 2, what that really means is I am starting at index 1, so the second element, George, John. I start at John, and then I go in there, and then I start a copy from there, but I stop before I get to the second, to index 2, right? So I stop before I get to the third element. And so essentially, if I think about what that means is I'm basically going to John, I start the copy there, but I stop before I get to Thomas. Well, all I've really done is create a new array that's just one element long, right? It's just John. And so what slice does, once again, is it makes a copy of either an array or a subset of an array. It does not change the original array, right? And that's oftentimes why we do it, is because we want to get a copy of the array that we can play around with and change and doesn't impact the original. And then lastly is, what does it return? Well, it returns back the copy that we just created. With that slice, it's totally fair to use documentation to look up what it does, because even I still get tripped up sometimes thinking about like whether or not, like what arguments it takes and in what order. Just know that was dot slice. Another shorthand that you might see people also using is just calling dot slice without giving any arguments, and that's just a shortcut for copying the entire array. So here, if I do names dot slice and I don't pass in any arguments, and I store that return value in names copy, well then what I've really done is here on line 8, I've also gone to names copy. I've gone to the thing at index 2, so position 3, I've changed to Paul, and I've also pushed Ringo to the end of this copied array. If I now look at names and names copy, we'll see that my names array was not changed, but on line 6, I made a copy of the names array, and then I was able to replace one of the values with Paul, and then I was also able to push Ringo in to the end of it as well. Any questions up to here? Everyone good? Everyone else good? Cool. Cool. Just 2 or 3 more of these, and then we'll wrap up for today. Dot includes is also another method. It works very similar to index of. It's also a search function, except this one doesn't even tell you if it finds a match, where it finds a match, or rather, it doesn't tell you where the match is. It just tells you as a boolean, true or false, if it finds the match. Right. So here I have my array, and I do dot includes, and I search for George or Alexander. I basically am only going to get back one of 2 options. I'm either going to get back true if there's at least one match. It doesn't tell me how many matches there are. Or I get back false if it doesn't find any matches. That's pretty much it, right? So it does not change the original array, and the return value is a boolean indicating if we found a match or not. And then last but not least, we have our reverse method. Dot reverse doesn't take in any arguments, it just does one thing, which is it takes the array and reverses the order. It does change the original array, so be careful when you use it. It doesn't really return any values because its functionality is in what it does, not in what it returns. So yeah, so use this one kind of at your discretion, right? And that's pretty much it for today. So just to recap, we talked about what is an array and how type of and array.isArray is different from each other. We talked about bracket access and bracket assignment. So basically, how do we use bracket to access values and then also replace them with other values? We talked about the dot length property, but also some of the other methods as well, like push, shift, unshift, pop, etc. And so today's lesson will be very much on kind of going over the basics of arrays. One thing to also note is that for today's workshop, a lot of these things we will be asking you to reconstruct your own version of things that already exist. So if we're saying, hey, can you create a version of index of, please don't use index of in your solution. It kind of defeats the purpose, because we want you to be able to kind of recreate it from scratch using for loops and other techniques that we've already been discussing. So on that note, any questions? Yep.
So you know how we talked about the complex types, and we said that there are arrays, objects, and functions.